Acha, so I told you make sure to draw as many diagrams when you're doing these questions, Tika. So you know what's going on. So I'm just going to write the equations first, just as a formality, NaOH with HCl. So we're going to do that. It's NaOH plus HCl, and that's going to produce NaCl plus H2O. And with ammonium sulfate, the reaction would be ammonium salts react with bases. Okay, remember, I sent you a PDF as well. Make sure you revise your reactions. And it's going to produce sodium sulfate, but that's your salt plus water plus NH3. And you can go on to balance this equation, which would be, I think, just 2 NaOH. And no, 2 NH3 as well, and 2 H2Os. I said, but anyways, that's your reaction. Now I'm going to discuss what's happening here. There's a fertilizer, and that fertilizer, you got a 2.96 gram sample of a fertilizer. So that's what you have. And that fertilizer contains ammonium sulfate. So not all of it is ammonium sulfate. And we need to figure out the purity of ammonium sulfate, like how much what's the purity of ammonium sulfate? What's the mass of ammonium sulfate in that particular fertilizer? So what he did was that he heated it with 40 cm³ of NaOH. So this is what he's doing. He added this into a beaker which contained 40 cm³ of NaOH. That's it. And that NaOH is in excess. That's another thing. So not all of it is going to react. And then what he did was that after cooling, the remaining NaOH was neutralized by this much HCl. So he takes the leftover NaOH, same beaker. Now it has the leftover NaOH. So this is the NaOH that he initially added, and this is the NaOH over here that's left at the end of the reaction. He then adds HCl to it. And the amount of HCl that's added is what? It's 29.5 cm³ of 2 mole per dm³. So the volume is given. And the concentration is also given. That's 2 mole per. That's 2 mole per dm³. That's also given. So the first thing is calculate the amount of moles of NaOH. I said the reaction isn't over yet. What he now does is, if you look at the third statement, he does a separate experiment, a completely different experiment. And this time he takes the same 40 cm³ of NaOH, which he used in the first reaction, the same one. So remember, remember this NaOH that he used is the same as the one he's talking about over here. And he reacts it with and he says that it exactly reacts with HCl. And the amount of HCl that it reacts with is 39.2. So that is 39.2 cm³. And the concentration is 2 mole per dm³. So remember, this experiment over here is a completely, this one over here is a completely separate experiment. Just a second. So this one, and so this one over here, the one that they're talking about over here is a completely separate experiment from the one that was shown over there. Now what we're going to do is, so now what's going to happen is, he is saying that if I highlight this over here, to get this part over here, what he's saying is calculate the amount in moles of NaOH present in the 40 cm³ of the original sample of NaOH. So what you're going to do now is, now listen to this very carefully. What's going to happen now is that he's asking you to find the moles of NaOH in the original sample. That is what he's asking for in the original sample. So can anyone tell me how much HCl is reacting with this original sample?
$29.5 centimeters.
Nini, over here, what's the amount of HCl that's reacting with the original sample? Like it's 39.2 cm³ of 2 mole per dm³. So how many moles is this? Let me just add a mouse to this just a second. So how many moles is this? This one.
2.
Nee, this is 2 mole. How do you find moles? Moles is concentration times volume. So what do? The concentration is given, it's 2 mole per dm³, and the volume is 39.2 cm³, which is going to be divided by 1,000. So how many moles do you get for this? This one over here. Can you even quickly do, Mars, can you do the math? What's
0.07484.
0.074?
84.
That's 84 moles. Are you sure? I think 30. You're getting 0. Why is there? Isn't it just 748? Are you sure it's 7484?
Yeah, 0.0784. There's no 4.
Acha, theek hai. 0.0784 moles. Acha, so NaOH and HCl react in 1:1. So the amount of moles of NaOH over here would be exactly the same. It's going to be, so the moles of NaOH would be exactly the same, 0.0784 moles. So this other experiment that he did, because remember, we had NaOH, 40 cm³ of NaOH in excess reacting over here. Like the problem over here was no one knew how many moles this was, right? So he did this separate experiment, like in a separate experiment, 40 cm³ of the original NaOH that he added over here. He did a separate experiment, and this time he reacted with the HCl, and he found out that this is the amount of HCl that reacts with it. And HCl and NaOH react in 1:1. So I found the moles of HCl, and I was able to find the moles of NaOH. So the moles of NaOH over here are coming out to be 0.0784 moles, which means that the moles of NaOH over here is 0.0784 moles. ये जो original NaOH था, that is 0.0784 moles. Is this point clear? Yes or no?
Yes.
So this other experiment was only there to figure out the moles of the original NaOH that you were adding over here. Okay, so this was a separate experiment. Mars, is this clear?
Yes, sir.
Okay, Raid, is this clear? So now he's saying calculate the amount in moles of NaOH present in the 40 cm³ of NaOH that remained after boiling. Now he's saying remained after boiling. Okay, the remained after boiling the ammonium sulfate. So now the thing is, we used these many moles of NaOH in the original sample, and it was in excess, so some of it was left over. Now he's asking for the leftover NaOH. So now you're going to find the moles of HCl again. Now this is a reaction that's happening with the leftover NaOH. Can you find the moles of HCl? It's 29.5 into 2 divided by 1,000. concentration times volume. What do you get for this?
.049.
It's a 4. Is 0 point?
049.
49 moles. So the leftover NaOH is going to be exactly the same, 0.049 moles, because NaOH and HCl react in the same ratio. So now you've got 2 moles. Yes.
I'm getting 0.059 moles.
एक second, 59 होगा. 59. ठीक है, so this would be 5. एक second, अब कर ले. So this is going to be 0.059 moles. So अब question solve हो जाएगा कि in the next part is going to ask you about calculate the amount of NaOH that react with ammonium sulfate. So these are the moles that were originally added, 0.0784. These are the moles that are left at the end of the reaction. So how many moles actually took part in this reaction? 0.0784 were added and 0.059 are left. So that means 0.0784 minus 0.059. What do you get? What do you get for this?
0.0194.
0.019. 4 moles. So these were the moles that were originally taking part in the reaction over here with ammonium sulfate. Okay. So I'm going to just go through the question again. He added the fertilizer into 40 cm³ of NaOH, and then it was in excess, so some of the NaOH was left at the end. Now, how did we find the moles of the 40 cm³ of NaOH? We did a separate experiment in which the 40 cm³ of NaOH reacted with this much amount of HCl. So we found the moles of HCl, we found the moles of the NaOH over here. And we found the moles of the leftover NaOH because the leftover NaOH were also being titrated with or reacted with HCl. We found the moles of HCl, we found the moles of NaOH that were left. अब फिर दोनों को subtract किया. These were the moles added, these were the moles that are left. We found the moles that actually took part in the reaction with ammonium sulfate, which comes out to be 0.0194 moles, right? So that means the moles that are actually taking part in the reaction with ammonium sulfate are 0.0194 moles. Is this clear to everyone? Sara, clear hai ye? Maaz, Zan, Sidra, is this clear? Afeen?
Yes, sir.
And in the next part, he's going to ask you about ammonium sulfate moles. So 2:1. So divide this by 2, you'll find the moles of ammonium sulfate. What do you get? What's 0.0194 divided by 2 into 1, 2:1? कितना बना मास?
9.7 multiplied by 10 to raise power minus 3.
9.7? क्या 2? 7? खाली
9.7 multiplied by 10 to raise power minus 3.
So anyway, so these are the moles of ammonium sulfate, and he's asking you to find the mass. So you can find the mass by multiplying moles by the MR, which in this case is NH4 is 18, 18 into 2 is 36, plus sulfur is 32, plus 16 into 4, that's 96. That would be 132. So moles is, sorry, mass is moles multiplied by MR. So what do we get?
1.2804.
So we're getting 1.2804
04.
grams, okay? And we have gotten this mass, and he's asking what percentage by mass. So how much ammonium sulfate, like how much fertilizer was added 2.96 grams. जिसके अंदर अमोनियम सल्फेट कितना निकला है? 1.2804 grams, right? So the percentage is 1.2804 grams is the mass that you got. So out of the 2.96 grams fertilizer, you got this much ammonium sulfate. So into 100, you'll get the percentage, which comes out to be what?
$43.3.
Okay, we're getting 43.3%. And that's going to be our answer. So is this question clear, everyone? Mask clear?
Ji, sir.
Sidra? Afreen, is this clear?
Yes.
So we'll try another one. TK, make sure you practice these. This one is an even more difficult question. So because it's got more steps now. So what's happening in this question is, okay, there is just remember that, I mean, doing the mole stuff is not that difficult. Comprehending the question is more difficult. So there's chili salt, whatever this is a mineral found in Chile and Peru, and which mainly consists of sodium nitrate. The mineral is purified to concentrate the sodium nitrate, which is used as the fertilizer in some fireworks in order to find the purity of the sample of sodium nitrate. So this is what you're doing. Sodium nitrate purity, right? We need to find that. The compound is heated in NaOH with Devarda's alloy, which contains aluminium. So that's aluminium. And ammonia, which is boiled off and then dissolved in acid. So this is what's going on. Ammonia is produced. And then this ammonia is taken and dissolved in an acid, right? So the ammonia that is produced in the reaction is dissolved in excess of sulfuric acid, and the sulfuric acid is in excess. So that means it remains unreacted. So the unreacted sulfuric acid is then determined by back titration. So that sulfuric acid is then taken, the leftover sulfuric acid, and it is reacted with NaOH to form salt and water. So hopefully this is clear. He takes sodium nitrate, ammonia gas is produced. The ammonia gas is taken and dissolved in sulfuric acid, which is in excess, and some sulfuric acid remains, and the leftover sulfuric acid is then reacted with NaOH. Is this clear? Okay, all clear? Is this clear? So you've got 1.64 gram sample of sodium nitrate. So this is one. And remember, it's not pure. So that's not this is not the mass of sodium nitrate. Anyways, it's reacted with an excess of the NH3 produced was dissolved in 25 cm3 1 mole per dm cube sulfuric acid. So the volume. So I'll just calculate the moles directly. Can anyone tell me how many moles this is? 25 into 1 divided by 1000. What do you get?
.0.025.
So you're getting 0.025 moles. Remember, that's an excess, right? And then when all the NH3 had dissolved, the resulting solution was titrated with NaOH. So the leftover H2SO4 was reacted with NaOH. Can you directly tell me how many moles this is? 16.2 into 2 divided by 1000. What is the moles of NaOH?
.0324.
So you're getting 0.0324 moles. So anyways, without even following the steps, we can actually do the whole question over here, because we have to figure out the purity of sodium nitrate. To figure out, we need to find the moles, the mass of this thing. We can do that by figuring out the moles of ammonia. To figure out the moles of ammonia, you need to figure out the moles of sulfuric acid. And to figure out the moles of sulfuric acid, we know the moles of sulfuric acid that were added. We need to figure out the moles of the leftover sulfuric acid. So we can use ratios 2:1. So if the amount of NaOH used is 0.0324, so according to 2:1, kitna hoga? What's the amount of sulfuric acid that's going to be reacting with it? 0.0324 divided by 2, what do you get? क्या आता है? What do you get?
Zero point 0.0162.
ठीक है, so 162 moles. So we figured out the moles of the leftover sulfuric acid, and these are the moles of sulfuric acid that were added at the start. So how much sulfuric acid was actually taking part in the reaction with NH3 or got used up? Okay, itna dala tha, 0.025 was added and 0.0162 is left. So can you tell me how much sulfuric acid actually took part in the reaction? 0.025 minus 0.0162, what do you get? What is 0.025 minus 0.0162?
8.8 into 10 raised to power -3.
So that means it's 8.8 times 10 power minus 3 moles. These are the moles of sulfuric acid that actually took part in the reaction. Or 1:2 है, तो इसको double करो, you'll find the moles of ammonia. So 1:2. So क्या होगा? What's the double of this?
0.0176.
176 moles. ठीक है, यहाँ तक आ गए. And I told you, if you find the moles of ammonia, you'll find the moles of sodium nitrate. Now remember one thing, the ammonia that is produced over here, all of it came from the first reaction. So how many moles were taking part in this reaction? 0.0176. So all those moles came from the first reaction. इसके अंदर confused ना होना कि this is 3 and this is 2. Remember, the ratio in the equation is between the compounds in the equation, not with the other equation. Okay, don't compare ratios of two separate equations because this 3 has nothing to do with this 2. This 3 is a ratio with water, with NaOH, with Al, and with sodium nitrate, not with this thing. So just remember, all the ammonia that got produced over here was used up in this reaction. So 0.0176 must have been produced over here, which is why 0.0176 is taking part in this reaction, the second reaction. And ammonia and NaNO3 are going to have exactly the same moles, 3:3. So we figured out the moles of sodium nitrate as well, which is 0.0176. So I'm just going to repeat everything now. Okay, he told us that there was excess sulfuric acid, which is 0.025 moles. And he told us the quantity of NaOH as well, that it was 0.0324 moles that was reacting with the leftover NaOH, H2SO4. So the ratio laga ke na we figured out that the H2SO4 reacting was 0.0162. We found the leftover H2SO4. We knew the original H2SO4 that was added, and we figured out the H2SO4 that took part in the reaction. फिर उसके ratio से we figured out the moles of ammonia. Once we knew the moles of ammonia, the moles of sodium nitrate were exactly the same. Clear है ये? समझ आया? ठीक है, Raid, is this clear? Izan, Amna, Afreen? Is this clear? Mass clear है?
जी सर.
तो उससे वो सारे steps पे किया हुआ है. He has given you all the steps, and the last part is calculate the mass of NaNO3. So you found the moles. So you can calculate the mass, multiply this by the MR, which would be 23 plus 14 plus 16 times 3. That's the MR. So what is the mass that we're getting? Kevin, has anyone done this? We're trying to find the mass, moles multiplied by the MR.
Sir, 23 से पहले क्या लिखा है sir?
Was a 0.016 multiplied by 23 plus 14 plus 16 times 3. NaNO3, you know. Moles multiplied by MR. सारे क्वेश्चन को जल्दी से कैलकुलेट करो स्पीड में, ठीक है?
1.496.
They're getting 1.496 grams, ठीक है? और उसने क्या कहा था? उसने he told us के 1.64 grams था. So find the purity, divide that by 1.64 grams into 100. He told us that the fertilizer, bulky whatever NaNO3 you had was 1.64. We found out that the actual mass is 1.496. So the purity is going to be what? What are we getting?
$91.2.
ठीक है, 91.2%. मेरे ख्याल से यहाँ पे percentage by mass, ठीक है? We found the purity. We found of the present in the impure sample, ठीक है? 91.2%. ठीक है, is this clear? This one. एक और कोई इस तरह का ढूंढ लेते हैं कि so we're done with this. अच्छा, there's more titration questions. Just a second. ये वाले कर लेते हैं. Let's try and do this one. You don't know how to balance these equations at the moment, so I'll just balance this equation for you. 5, 8, 4. So ठीक है, balance हो गया. Anyways, this is the balance equation, and he's saying that there's a thing called Mohr's salt, and it's पता नहीं उसमें NH4 भी है. It's got Fe, it's got SO4 as well. So it's ammonium iron 2 sulfate something. X represents the number of moles of water in 1 mole of the salt. So we need to find X. Student wanted to determine the value of X. So 0.784 grams of the hydrated salt was dissolved. So first thing, the very first thing is, so the very first thing is, we know the mass he's using. He's using 0.784 grams. Now the question is, what is he doing with it? So it dissolved in water and the solution was acidified. So he makes it into a solution. So let's say a beaker ban gaya, and he dissolves it in water and makes it into a solution. And all of the solution was titrated with, so the whole solution is being titrated with what? ऊपर से ना वो डाल रहा है, he's adding potassium magnate, which is MnO4 -1. So he's adding KMnO4 or MnO4 -1, and the volume and concentration is given. Can you figure out the moles of KMnO4 that he's adding? Well, the concentration times volume, 0.02 into 20 divided by 1000. What do you get? The part 3, he's asking that. What is 0.02 into 20 cm cube? This part. Divide by 1000.
4 multiplied by 10 to raise power minus 3.
So yeah, आगे 4 times 10 per minus 3 moles आगे. We have the equation as well. So I know the MnO4 moles are 4 times 10 per minus 3 moles. So we found that. Now he's going to ask for the moles of Fe2 plus iron. So what's the ratio? 1:5. So multiply. Yes.
10 raised to power negative 4 is sir.
20 divided by 1000. देख लो, मतलब एक दो फिर चेक कर लो. Mass. मैं तो कर देता हूँ 4. Just make sure कि it is the correct one. ठीक है? तो इसको कर देते हैं -4. Just double check. Anyways, we'll pick it अगले part. He's asking you to find the moles of Fe2 plus ions. So it's 1:5. So that means the moles of Fe would be multiply this by 5. What do you get? कितना बनता है if you multiply this by 5?
Two into 10 raised to power negative.
So you found the moles of Fe, right? अब ये कि so you found the moles of Fe. Now he's asking, calculate the formula mass of this. अच्छा, पहले तो ratio. ये एक salt को dissolve किया था, you got Fe, right? So I mean, whatever Fe, you got Fe2 plus, right? So the point is, one salt, like this entire molecule, is going to produce one, because it has one Fe, right? So the ratio is one molecule produces 1. So अगर आपके solution में there are 2 into 10 per minus 3 moles, so the amount of salt that would dissolve would also be exactly the same. क्योंकि ratio क्या है कि if I dissolve this entire thing, I'm going to get just one Fe. Like one of this would produce one of this. So that means if I'm getting 2 into 10 per minus 3 moles of the Fe2 plus ions in the solution, then I must have dissolved exactly the same amount of moles of this salt. Is this clear? Ye clear, Sidra? Is this clear?
Yes.
So just remember that the moles of Fe2 plus and the moles of the salt over here are going to be exactly the same. Because one molecule of the salt, one formula unit of the salt contains exactly 1 Fe. If you had 10 of these, there would be 10 Fes. If you have 2 into 10 per minus 3 moles of Fe, there would be 2 into 10 per minus 3 moles of this thing that were dissolved in the solution over here. As anyways, he's asking you to find the formula mass. So we know that moles is mass divided by mR. And we know that the formula mass, which is mR, is mass divided by moles. We do have the moles, we do have the mass as well. Both things are known. The mass was already given. It was given as 0.784 grams. So that was already known. 0.784. The mR, sorry, the moles are 2 into 10 per minus 3 moles. Can anyone quickly tell me what's the mR now? You can remember he gave you the mass of the salt initially, and you figure out the moles of the salt as well. So what would you get for this? कितना है, क्या वैल्यू आई है हमारे पास? Anyone? Read what are you getting, Mars, Sidra?
392.
The exact 392.
Yes.
So, ठीक है. So I'll just quickly recap this question. You had 0.784 grams of the salt that was added to the flask. And he said that there was MnO4 potassium magnate that was added from the top. The volume and concentration was given, so we figured out the moles of MnO4 minus 1. And we figured out the moles of MnO4 minus 1. We also figured out the moles of Fe by multiplying that by 5. And we got 2 into 10 to the minus 3 moles. The next part was, okay, I said that the moles of Fe and the moles of this entire salt are exactly the same, which basically means, like, if you have NaCl and you're getting Cl minus 1 ions out of it, it's the same moles. Like, if you have 50 of them, there would be 50 Cl ions that would be produced, right? Because the ratio is 1:1. So the point is that this one molecule contains one Fe. So if you have these many moles of Fe coming out present in the solution, the moles of this salt would be exactly the same. The last part where we were able to figure out the MR of the, because the mass was given and the moles were also given, we were able to figure out the MR. Ab aakhri part hai, I guess you have to figure out X. So everything should add up to be equal to 392. So it's NH4 twice, so that's 18 into 2. Fe, I think, is 55.8 plus SO4 twice, that's 96. 32 plus 16 to 4, and then twice. Plus there's X water molecules, so X into 18. All of this must add up to be equal to 392. Right? The whole thing should come out to be equal to 392. Can you try and figure out what X is? And quickly tell me what the answer is.
X is 5.
Okay, so X comes out to be equal to 5. So that is the value of X that we are getting. So just make sure, try, and you have the worksheet with you, try and practice these questions again. TK, make sure you get used to it. I mean, these are the most important questions in moles because the other ones are just for 1 mark. I mean, the other ones, the smaller ones, the MCQs, etc., they're not that important. Like, even if you miss one of them, you'll just lose 1 mark. But this is like, I mean, most of these questions are like 8 to 10 mark questions. So they're going to really, really matter in your grade. So make sure you practice these titration questions. And this one is on page, I don't know what the page is, 99. So make sure you try and practice more of these, TK. So, okay, everyone. Let's continue on Monday then, ठीक है? Okay. Allah Hafiz.